my brain that the major axis went like that and the minor axis went where? Like that. Do you see how it worked? It's going off that way. I didn't try to make it stand up straight. And if I want to do that one, I can kind of figure the major axis is going to have to be like that because the axle would go, and then I can kind of fit it on there. Actually, it would be right about there. Oop. That's how I tested. That is not, I still did not get an accurate cube. It's off that much. See, this is not an ellipse. It's more like an egg shape. I'm trying to shave it in there when it ought to be like so. Oh well, you know, you try. You fail, you get your templates out. Does this make sense, what I'm doing though? The placement of this ellipse. Think of the minor axis as the end of an axle. And that axle goes off into space. Minor axis, end of an axle. Axle goes off into space in 2 points. Now, I had this problem many times in trying to place ellipses, and I never figured it out on my own. And it was in 1986 that I was sitting at a bus stop on Magnolia in the afternoon, waiting for the bus, reading Ernest Watson's book. And I was in the chapter on circles and ellipses, and I read that section and got it. That's how you do this. And I thought, I've got to test this. And I was watching cars drive by, and I would watch the wheels of the cars. Remember, the cars, unless they're right there, profile to you, in which they're in 1 point perspective, when they're coming toward you from your right, coming toward you from your left, as you turn your head, they're in 2 point. And I would notice that as I'd watch the angle of the ellipses that made those wheels, they were at an angle like this, and then as they'd come in front of me, they'd go like that and become a circle, and as they'd go away from me, I could see them tilt. And even though I was sitting at a Magnolia bus stop inhaling people's exhaust fumes, it was sort of a blissful feeling. Because I was seeing it works. This is the trick to how ellipses get placed on objects that are not in 1 point. That's the way you do this, and that's how come we built these things for the perspective class and drew these in every conceivable position and then tried to find, see, that line and that line are not the lines for making the ellipse. These are lines for figuring out how the circle is divided, and you will find in your imagination, you will find where the lines are to make this business. And one of the secrets is if it's in 2 point perspective, that minor axis must go back like the bar on a barbell. It's going to go back there like that, along that line. And then if you can always think that way, there you've got your symmetrical ellipse. It will go on like that.
You know, the way to think of that is having two pieces of cardboard like this. You know?
Oh yeah, okay, right. So that you know you distinguish between 2 different planes. This plane would go back like that. This plane would go back like that. Okay. Oh, another thing about this that you should know. I'll try a third time. See if I can get this to make this point. Let's imagine it as a clock face. Clock face in 2 point perspective. We want to find the center of that. That's where the pivot is going to be for the hands. It's got to touch at these 4 points. How will we know? We've got to run a line like that, and that will be the minor axis. I have a feeling I'm going to get in trouble. Nope, it's working this time, folks. I'm doing it. I can't believe it. Okay, we've got a pretty close to a circle in space there. A little bit of forcing it at the edge. Little problem right there where we need to pull it out. Remember, major axis, minor axis, right? You know how we found the minor axis. Remember what we talked about at the beginning. That has nothing to do with where the center is. We need to know the center, and we need to place the angle. I've been talking for the last 15 minutes about placing the angle of the ellipse. Let's get back now to knowing the center. There's the center. That's the center of the ellipse, but there's the center of the clock from which the hands will come out. Where is 12 o'clock? Is 12 o'clock there? No. So that means the major axis has nothing to do with up and down. You would find the major axis, or where 12 o'clock is, by finding the middle and running a vertical line parallel to those like that. And that's where 12 o'clock will be, and that's where 6 o'clock will be. What about 3 o'clock and 9 o'clock? You know that they're not going to be here and here, where the minor axis of the ellipse is. How do you find them? You run a line halfway, you just measure, halfway down, or you can run through that point back to that vanishing point, and that line is going to go off to that vanishing point, and that's where 3 o'clock and 9 o'clock are going to fit. The point is, these crosshairs, this perfect symmetry, is only for drawing the ellipse. It has little to do, nothing to do, with where the center point of the circle it represents is, nor where vertical and horizontal are on the circle that it represents. Okay? Does the major axis go through the center? On this one, no.
No, the minor axis.
Does the minor axis go through the center? Not necessarily, no. Although it comes so close that you kind of, there's only one way that a true symmetrical ellipse will fit on there. And it depends, it has to do with the severity of the angle. But yeah, you'll find that I just go through the middle to kind of place it generally, and then you're going to have to refine it down. Which brings up a point. To make practical use of this, the problem with anything scientific like this as it relates to art is that you can easily experience paralysis by analysis. That is, you start thinking about all this stuff when you're starting a drawing. Don't. Unless you're doing a technical cutaway of an airbrush, right? Which you've got to start thinking, and the major axis is going to be like that, the ellipse is going to be point of view like this. If you want to evade paralysis by analysis, I suggest sketch first and then correct it later. A novelist was trying to write the perfect novel, never got beyond the first. He'd been working on the first paragraph for years. The reason why is because he was trying to write the perfect novel. He shouldn't have been doing that. He should have been trying to tell a story, jump into the story, do the story, and then you go back later and say it's got problems here and fix those, and then you go back and got problems here and fix that. But as soon as you're trying to place everything perfectly, you will not create any more than you will be able to speak if you're thinking about grammar. Does that make sense? Sketch first, get it in there the way it's got to get in, and then later go in and say, this is wrong, shift that there. So you will be surprised how much it might change. But you don't start out thinking this way. Jump in first. That's if you want to make practical use of this. There is another harder, longer-term way. It's called mastering this. And it takes more than a few weeks. But if you want to master this, where you can draw like this, where you've got all of the stuff correct, as easily as you speak, and the grammar comes out right, as easily as you walk without tripping, which you did a lot when you were an infant, if you want to draw with that kind of effortlessness and get it right, then you've got to do something that Ernest Watson in his book said that he recommended this ratio of theory to practice. 1 part theory, 1 part of what we're doing here. How many parts practice? Anybody read it? 50 parts practice. That's a bit much. 15 would help you a lot. You know, 1 part theory, 15 parts practice, 20 parts practice. He said 50. And of course, he's coming from the old school where to be trained, you had to do this effortlessly, like a master. I went through Nicolaides. I got about 75 hours in the Nicolaides book, The Natural Way to Draw, in which he had you do hours and hours of gesture drawing. And one of the things that I did gesture drawing from at that time was a telephone cord. It wasn't just gesture drawing. I'm sorry, I meant to say that he had you do cross-contour drawing and do things where you're trying to wrap lines. You're looking at the object and you're kind of doing this, you know, and trying to wrap lines around there. And so I would look at a telephone cord, which is a pretty complicated thing. You know, it's a helix, and it's got distinct planes that curve like so and then like so. And I was doing my contour drawings by looking at that, but I hadn't studied perspective intensely, and it helped me. It helped me because I started to think about space on paper. It would have helped me more if I would have been studying perspective and then doing my Nicolaides, and that way I'd be thinking about the placement of these ellipses. And what happens when you do that? You drive it into your subconscious mind so that eventually it does become effortless. That's the way you master it. You can make it practical by just sketching first, correcting the problems later, but I suggest that if you want to be a master, that the long-range thing that you shoot for is to get it so that it's natural to you. Here's how you can test whether you've got it. If you can take a sphere, if you can take a circle and say that's not a circle, that's a globe, and you can tell where the top point is and where the bottom point is through there, and you can wrap those ellipses around there to place how far it's tipped down. And if you can slice that thing one way or another, say I'm going to take a slice across there, and know how that slice would look, and be able to place it without using templates, and slice all different angles, then you've got this part mastered, this circles and ellipses business. Okay?
This is an oxygenator I drew and rendered with airbrush. I did the outlines with ballpoint pen. Its basic construction is a cylinder. All of those tubes that have been cut away are cylinders, and the ellipses that describe their cross sections are placed according to that axle analogy. The lower ones tip more than the upper ones because the minor axes on the lower ones go up to a vanishing point more severely than the upper ones.